All right, so hopefully you had some chance to practice F2 on IXL. Remember, you have to have an 85% to get 100 in the grade book. So down here, this is a little activity that you can do. You might want to pause the video and work through this and then come back and see if you did it correctly. This problem should already be worked out. I'm going to go ahead and label this triangle map, because it told me to. Well, that was interesting. So that's MAP. Then it says highlight side MA. So this side right here is MA. So I'm going to highlight it and highlight AP. So I'm going to highlight this side right here. All right. Color the angle for side MA and AP. So that would be this side right here. So I'm going to color this in. This is angle. An included angle is an angle formed by two, and so we would call these two sides adjacent sides of a polygon. Okay, so A would be the side that's included between the side lengths of MA and AP. That's what we call an included angle. Okay, so that's going to be important vocabulary for what we're going to come across coming up. So let's go ahead and label this triangle HOP. And it says in triangle HOP, what is the included angle between HO, so that would be this side right here, and OP and HP, which is, oh, I'm sorry, that's OP. Ignore that. You want to do this side here, HO and HP, which is right here. And so that's going to be the included angle is angle H. There we go. Okay? So please remember that's what an included angle is, and that's going to be important for us to prove that two triangles are congruent using side, angle, side. You need to have two sides that are congruent, and then the angle in between. Okay, so let's go ahead and do this exploration. Once again, you're going to want to pause the video at this moment, and you're going to use your protractor, and you're going to measure the following angles and side lengths using your protractor, and then come back to the video when you're ready. When I measured the following sides and angles, and again, our measurements might be a little bit off, but I measured angle A to be 60 degrees, and I always like to write it in my drawing as well. And then side length AC was 1.5. And side length AT was 2.5. Okay, and then when I did the same thing on the other triangle, I found that the measure of angle D was also 60 degrees. And I found that the side length of DO was 1.5. The side length of DG was 2.5. And then I said, do you think the triangles above are congruent? Well, I said yes. The reason I said yes is A, I know this postulate, but also because they look very much the same. And then it says, do you know that the triangles? No, we don't have enough information yet to prove that they are congruent, but we're going to find out in a second that in fact they are congruent triangles. So if you continue the exercise, if you measured CT, I got it to be 2.25. The measure of angle C was 83, and then I got 37 degrees. Now again, these might be a little bit off because it depends on how well you can read the protractor. But just know that 60 plus 83 plus 37 has to equal 180 degrees because there are 180 degrees in a triangle. And so now do I know the triangles are congruent? Yes. So is measuring the two sides and the included angle enough? Yes. It has to be the two sides in the included angle though. And what we call this is postulate SAS, side angle side. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then they are congruent by SAS. Okay? So there's a couple different ways that we're going to see this picture. Number one, you'll see the picture that looks like this, where literally everything's just blatantly obvious and it's marked for you and everything. We might see this situation. So let's see what's given. We've got these two this quadrilateral with two triangles inside of it. PR is equal to ST. So let's go ahead and mark that. PR is equal to ST. Angle PRT. So PRT is this angle here. And angle STR, which is this angle here, are also congruent. Can we prove that these two triangles are congruent? Well, yes, we can, because you can also see that this overlapping with the reflexive property, you can say that RT is congruent to RT based on the reflexive property. So yes, we can say because of SAS, these two triangles are congruent. Okay, let's look at the second example and let's see if we can prove that these two are congruent. So we've got AB is congruent to CB. So AB is here, CB is here. Okay, and then we've got AD is congruent to CD. So AD is congruent to CD. Okay, can we prove that these two triangles are congruent? Well, yes. Okay, because we can also say, because of the reflexive property, that BD equals BD. But this time it's not going to be side equal side, it's going to be the side, side, side postulate that we learned last week. So you need to be able to prove using side, 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 or side angle side that the two triangles are congruent. And again, the picture always isn't going to be pretty like this, where it shows exactly what it looks like. Okay, let's look at another example. We want to prove using side angle side. Okay, here's our picture. So you want to copy and complete the flow proof. So the first thing we want to say is that RX and XX are congruent, and QX and TX are congruent. Well, that was right here. That's our given. Okay, so now what else can we say is congruent? Well, we know because of vertical angles that these two angles are going to be congruent. So that's where we can say that QXR is congruent to TXS. And that's what we call vertical angles congruent. Okay, and lastly, we can say that triangle QXR is congruent to TXS. So this is kind of a different flow proof than what we're used to, but it all comes down to the same information in the end. Okay, there is no postulate that is the SSA or the ASS postulate. There's only the side angle side. So don't be a donkey and get fooled by this. All right, let's look at another example. Why don't you go ahead and see if you can work on this by yourself. And then we'll come back and check your answers in a second. Here we go. We are going to prove so some things that we know. So it says write down everything you know about the given triangles. Where we know that MO equals OQ. And we know that NO equals PO. Maybe it'll work. MO equals QO. And we know that NO equals PO. And we know also, because of vertical angles, that these two angles are going to be congruent. So we know that MON equals, or is congruent to POQ. All right, so now we want to write a flow proof or a two-column proof to show that the two triangles are congruent to each other. And so to do that, this is basically what we're going to start with. We're going to start with, well, I'm going to write a two-column proof. Okay. So for a two-column proof, you basically like this and like this. And, Lord, sorry, my thing's working a little slow today. On this side, you're going to have your statements. And then on this side, you're going to have your reasons. There they are. Sorry, it's sloppy. So my statements basically are the stuff in this box that I know about the two triangles. So first of all, I know that MO is congruent to QO. And that reason for that is given. And then I know that NO is congruent to OP, and that as well is given. And then the next piece of information is here, that angle MON is congruent to angle POQ. And we call that, those are vertical angles. You'll see this one a lot. Vertical angles are congruent is the shorthand way of saying it. And then lastly, I can say that triangle MON is congruent to triangle QOP. And if I look how I marked up my drawing, I notice that I marked up a side, an angle, and a side. So I'm going to say this is because of side angle side postulate. Okay, so to write my proof from scratch, the first thing you got to do is list what you know about the picture and then give reasons for it. So sometimes I'll give you the reasons and then you just have to list. So this is kind of what IXL is going to look like. So we know that GJ bisects this angle here, HGI. The word bisect means to cut in half. If you cut something in half, you have equal parts. So because of the definition of an angle bisector, I know that this angle and this angle are congruent. We want to complete the proof to say that the two lines are congruent. There's another piece of hidden information that I can use using the reflexive property, and that's telling me that GJ right here is congruent in both triangles. So if I split these triangles apart, they would both share that side. So now I got to look. Okay, it says GJ bisects HJ. That's given. This is GAI is equal to GH. That was also given, though it wasn't written. It was given in this mark and this mark. Okay? And then it says that these two angles are going to be congruent, which we marked, and that is because of definition of angle bisector. Bisect means to cut in half. And then we did also mark this angle right, this side right here. That's reflexive property of congruence. And so the last thing is telling us, well, how do I know that these two triangles are congruent? Well, I can see that I marked a side, an angle, and a side. So that would be S, A, S. Okay, here's another two-column proof. So it tells me that O is the midpoint of MQ, and because of that, because of this keyword midpoint, we know that these two sides are going to be congruent, and then we know that O is the midpoint of NP, so that's how I can say that these two sides are also congruent. And then the third markup that I need on here is that this angle is going to be congruent to this angle because of vertical angles, right? So my next statement here is definition of midpoint. So I can say that MO equals OQ. And I can also say that NO equals OP because of midpoint. And then the next statement, there should actually be a 5 here. I apologize, that was a mistake. The next point is saying that angle MON is congruent to angle POQ, and that's because of vertical angles. And lastly, you can say for SF. So lastly, we can say the two triangles are congruent because of SAS. All right, so you're going to